So first thing we'll do is check the pressure for us.
I haven't used one of them before.
Make sure it goes in straight.
Flash.
20 psi. Everyone write that down. We'll need it later.
Where do we write this down?
Wherever you want. Keep a record of it, put a note in your phone.
On the table.
Right, so
Sure you want to say that down?
So when I measure temperature, the first thing is you want to stick your probe straight in. Intentionally on the tyre, you could damage it and go through a cord or something like that, especially if it's well worn. Always come on the 45 angle. You notice that probe's got a taper on it. Yeah. So I come in on the 45 and just go up till it hits the taper. Make it some good depth, goes across, gets good carcass measurement. Yep. So if we get the cross on the measurement there, you can see that what's that temperature?
19 degrees C.
Alright, just want to pull it out and have a go yourself.
It's cold.
It's cold, so it'll be nice and hard to get in there. 19.
19 again.
Alright, that's cool. So I've measured that in 2 spots, 19 degrees. We'll probably record that one.
I'll take it down. So we're now going to put it
outside.
We're going to put it outside in the sun. We're going to hopefully increase its temperature, and then we're going to all try and predict later what its pressure will be. So
I could one day. Nick Davis's tyre was like overtaking me. It's just his tyre, not his vehicle. Just the outside inside the car.
So what I'm about to show you is based on theory, but it's a new way of looking at vehicle handling. So the reason why I use it, not just I talk about it, I actually use it, is because it takes in a very complicated field of vehicle handling and it puts it together into a simple model that you can use quite easily. And you can always refer to it. If you don't know where to start, you always refer to this and it guides you. So again, this is just an introduction, so we're going to go through it to a point where it's useful, and after that, to master it, you need to spend time using it. And we have a demonstration at the end, which we'll use it for. So the first thing we need to do is classify the different states of vehicle handling. And the two most significant states that we understand is called steady state and transient. Steady state basically refers to a condition where the inputs and outputs are not varying much at that instant. Now, everything is transient on a race car. You're always bouncing around, steering, moving, etc. But there are some parts of the state of the car which we call, for example, mid-corner, where the car actually has time to set. And that's, you would have heard the drivers and engineers talking about taking a set, for example. So, in case of a race car, a constant trajectory would be like a skid pan or a long sweeping corner where we're not really correcting, it's just a constant, that's what we call a steady state. Another example is when the car's settled through a corner. So it's turned, it's settled in, and it's leaning on the rear, leaning on the front. Typical example is a skid pan. Do you guys know what a skid pan is? Anyone need me to explain that? Basically, you've just got a big flat patch that you have to turn, and you just do constant radius turns. And the car's settled, just constant speed, and you're building up your speed, and you're measuring your, first of all, your overall grip and your balance at those different speeds. In terms of transients, basically the loads on the contact patch and the inputs have a time component. They're varying with time. Okay? And it could be every hundredth of a second, every thousandth of a second, or every tenth of a second, but there's a variation. Okay? And it's normally when we're transitioning between steady states. So for example, if we're on a skid pan and we're going around left hand or clockwise, and we decide that we're going to swap over and change directions and join another circle.
This next statement, I think, is figure 8.
Thank you. Figure 8. So we're on a skid pan, and we're constantly going around this circle, say in a clockwise direction. at one point we may want to transition over to the next circle, and we'll go this way. And so at this point in here, we'll have a transient where we're going from turning right to straight to turning left. That's all steady state, that's transient. Okay, another thing that we mentioned here is lane change, which is like you might be following a car in a slipstream and you decide to duck out. So there's that moment where you're steady state, you're following, you're tagging along, and you decide you're going to pull out, and instantly you've gone into a different roll scenario, different loads on the full contact patches. Okay? So, I introduced to you this vehicle handling model, and I just call it a handling model because I don't think it's anything special other than it represents all of the 4 possible scenarios of handling that we would ever want to describe or fix. So if anyone could tell me give me examples of handling problems that drivers complain about. Eric?
Understeer.
Okay, that's balance. Rich?
Turning.
That's response.
Oversteer.
Balance.
Lockups.
Lockups would be, could probably be grip, or, mostly grip.
Go down.
Grip.
Yeah, I was going to say wheel spin.
So there's really not much else that you keep throwing things at you, it comes into one of those 4. Okay? Now the reason we've got them shown like this in the graphic, we've got them shown because we want to highlight the significance and the importance and the order in which we need to solve the problems. So, okay, so stability is high, it's the top, it's the most important thing. Okay? We're not going to search for grip if the driver is complaining about stability. If he's worried that the car is going to spin through turn 1, you're not worried about the lateral grip at turn 2. You have to build on them. So I'll quickly define each of those states.